content in continuation, structural matrix analysis on trusses, the coordinate transformation, member and displacement, and forces. The member and displacement and forces. Ano ngayon yung displacement and deflection per member? At saka yung forces on each member, whether they are in tension or in compression. Again, you'll have to identify your nodes, your members, your near far, and your composite axis. Okay? Then transform the local matrix into the local stiffness matrix into global stiffness matrix. Okay? So by doing so, on our local coordinate system, we have the equivalent forces on the members. Okay? Acting on the members. On a global coordinate system, we have the component forces, horizontal and vertical, on each end point or end nodes. Same goes with the deflection. As shown in this figure, the orientation of M or the member, is relative to the global x and y coordinate system, which is defined the angle theta, measured counterclockwise from the positive direction of the global x-axis to the positive direction of the local x-axis. Recall the stiffness matrix K, then derive the preceding section, relates the member and forces Q and end displacement U. Then describe with reference to the local x and y coordinate system of a member. So how do we do that? First is for you to identify your end displacement in global coordinate system. Okay, hanapin natin ngayon yung mga probable deflection within the member. Remember that we have solved the deflection on 1, 2, and 3. Hanapin natin on each member saan doon ang merong deflection with respect to 1, 2, and 3. Which gives us V1, V2, V3, and V4. With respect pa rin yun sa near far node. And next is for you to identify your end displacement described with reference to the local and x and y coordinate system of a member. Ano naman ngayon yung end displacement with respect to the local matrix. Ito with respect to the global, ito with respect to the local, no? By multiplying the transformation matrix of the member times the identified end displacement on global coordinate system. Transformation matrix, then your member end forces. Your member end forces, whether they are in tension or in compression, should be now equal to the local stiffness matrix of the member times the end displacement on the local coordinate system, U. So, marami-rami yan. Kunin natin si V, si U, then multiply LK, or local stiffness matrix, with U to compute the member forces, which is your Q. If Q1 is negative and Q2 is positive, then the member force is in tension. If Q1 is positive and Q2 is negative, then the member force is in compression. Para mas madali, apply natin agad. On our given example from last video, we have already solved the deflection on node or on directions 1, 2, and 3, such as shown. Member 1 has near far nodes 4, 5, 1, 6. Apply natin si end displacement V on global coordinate system following the near far node 4, 5, 1, 6. On that node or on that near far node, yung U1 lang yung may deflection. So the rest will be 0. So 0 si 4, si 5, and si 6. Then, multiply that to the transformation matrix on member 1. Transformation matrix in member 1 times V in member 1 gives us the U or the end displacement of member 1 with respect to the local coordinate system. Yung paganyan. Parang kinonvert lang natin siya, no? Which is 0 of 0.005. Then multiply U with the local stiffness matrix. Remember kung ano yung nauna. Local stiffness matrix times the end displacement on local coordinate system gives us Q of negative 80 and 80, or simply 80 kilonewton in tension for member 1. Okay? Member 2. Again, ito yung ating 1, 2, 3 na deflection. Ito yung ating member. Identify your global coordinate and displacement for 5, 2, 3. Yung 2 and 3 lang yung may deflection. So, doon natin ilagay si 2 and 3. Multiply V with the transformation matrix of member 2. Transformation matrix times V gives us the end displacement with respect to the local coordinate system, 0 and 0.005. Then multiply that with the local stiffness matrix of member 2. And basically gives us the force on member 2 at negative 80 and 80, or simply 80 kilonewton in tension. And lastly, for member 3, deflection 1, 2, and 3. Member 3, node 2 to 3, 1, 6, 2, 3. Apply on the end displacement of global matrix, a global coordinate system, 1, 2, 3, and 4. U1, V6, U2, V3 based on near far nodes. Substitute nyo lang yung known displacement sa part na yan. Multiply to the transformation matrix of member 3. Gives us this value. And multiply that to the local stiffness matrix on member 3. Gives us 133.136 kilonewton in compression. Then, lastly, draw your result for the entire truss. Draw your result. How do we do that? Your reactions. Na-compute na natin yan kanina. Your deflections on each node. This is your 1, 6, 2, 3, 4, and 5. Remember, 4, 5, 6, 0. So, x and y axis na yan. X, y. 2, 0.00194, y, 0.005 vertically. Then, the member forces. Tension, tension, compression. Okay? For our next example problem, try to solve first on your own this given problem. Designate your nodes, then designate your elements. Hanapin yung near far nodes and kayo nang bahala. That'll be all. I'll see you on our next example problem. This time, we'll have to apply it using Excel para mas mabilis, no? Ang haba dito pag PowerPoint, isa-isahin ko pa. Mas mabilis tayo pag Excel. That'll be all. I'll see you on our next lecture video. Bye-bye.